Hello, everybody. Hope you guys are enjoying your digital days. Sorry, opposite of snow days, right? These are beautiful spring days. So hopefully you guys are getting out there and enjoying some good weather. So today, what we're going to do in this video is I'm going to check homework. Okay, so hopefully you got the homework done. I will be looking for it before class or Tuesday morning sometimes. See if you guys did it. I'll be a little lenient on when you actually get it done, but for sure have it done by Friday. Hopefully you've already finished it. So the answer key is posted in Content Library, but I'm going to go over it a little bit in this video also in just a second. And then I'm going to cover the material that I did not get to cover last class. So honestly, this is actually a little bit easier than what we have done so far in this unit. But we're going to complete those notes today. They are on this page. Tangent lines with implicit differentiation. Then your homework is some more similar problems to that in the book. I've included the homework page. I pushed that out to you, and I actually copied the problems for you. So you're all set. So first, let's go ahead and look at the answer key to homework. Okay, so again, the first four, I'll let you guys look at this kind of on your own. But the first four problems are pretty straightforward, right? No product rule, just applying the implicit differentiation rules. So hopefully you guys can follow along with that and check, see how you did. I want to just kind of tell you what I did on the rest of them. So when there was a product rule, I went ahead and highlighted it in the original problem and highlighted how I took it in the derivative. So for instance, on number 5, 5x to the third is 15x squared right here, right? And then negative 3xy is the product rule. So I had to use the rule of derivative of the first. So negative 3x is the first function, right? And then just y to the first is the second. So with the product rule, I did derivative of the first, which would just be negative 3 times the entire second function, which would just be that y, plus the derivative of the second function, which again is y. So the derivative of that would be 1 dy dx times the first, which is negative 3x. Okay? And then to go to this, so that's this first step. So to go to the second step here, I just added the 3y over to the other side. And then I just rewrote this term. Again, we talked about that in class. I like, when I'm taking the product rule, I like to write it out just as I'm saying it, like derivative of the second, which is that 1 dy dx times the first. But all of those are just being multiplied together. So when it comes time to actually using that term, it's helpful to rearrange them. So this whole term becomes really negative 3x dy dx. Okay, then when I had to divide through by negative 3x to get the dy dx by itself, and then I was able to divide through by 3 on all the terms to simplify it. Okay. If I look at number 6, again, in the yellow here is the product rule term right here. So I took the derivative of 1, I got a 0, derivative of 3x, I got a 3. And then again, looking at this, 2x squared is the first term and y squared is the second. So over here is how I took the derivative of that. Derivative of the first term is 4x times just the second term, or second function, no derivative, plus derivative of the second function, which again is 2y dy dx times the first, which is 2x squared. Now again, the next step down here, I subtracted the 4x. Actually, I subtracted both the 3 and the 4xy squared over to the other side, okay, because I had to isolate the dy dx. Again, over here, I just rewrote that term. All of those are just being multiplied together, so I can rearrange that term to be 4x squared y dy dx. Okay, again, there's no plus or minus in there. Okay, then I just divided by 4x squared y to get the dy dx by itself, and this was my final answer. Okay. Number 7. Okay, again, this had 2 product rules. Okay, so the blue highlight is the first product rule, the green is the second. So again, on this first one, the first function is 3x squared, the second function is y squared. When I apply the product rule, it is derivative of the first, which gives me 6x, times the entire second function, which is y squared, plus derivative of the second function, which is 2y dy dx, times the first, which is 3x squared. On the other side of the equal sign, derivative of this of 4x squared is 8x. Now the green, again, I have to use the product rule. The first function is negative 4x. The second function is y. Derivative of the first would be negative 4 times the second function, which is y, plus derivative of the second function, which is going to be 1 dy dx, times the first function, which is negative 4x. Okay? Then, second part, I kind of did a couple things. Hope this is not too confusing. But I went ahead and subtracted the 8x over to the other side and added the 4y over to the other side. Okay, just to get all of my non-dy dx terms over on the left-hand side. On the right-hand side, I took this term. Again, I rearranged it because it's all being multiplied together, so I just multiplied that 2 times 3, and then made it x squared y dy dx, and subtracted it over to this side. I went ahead and pulled out the dy dx, and then also pulled out the dy dx from this that was already there, and brought down the negative 4x. Okay, so that stepped a few things there, but hopefully you guys can follow that. Okay, now to get the dy dx all by itself, I'm just going to divide by negative 6x squared y minus 4x on both sides. Then it looks, and I get this. Now you can tell I can take out a 2 from every term, so I will. Okay, if one of these terms happened to have been odd, I couldn't have simplified. But because they're all even, I could take out a 2, and this is my final answer. Okay, so again, hopefully you guys, you're able to follow this. And again, if you have other questions, we'll go over it again on Friday. Okay, the last 2 were book problems. I think that was everything. Oh, okay, and then number 8, sorry. Number 8 here, I again highlighted the product rule terms. So everything in yellow is taking the product rule of x, y squared. Everything in blue is taking the product rule of 5x to the third, y to the third. And then again, I brought all the dy dx terms over to the right, everything that wasn't dy dx to the left, and divided. Okay. I will remind you guys, if because now these are a little bit more complicated, if you have every single sign wrong or different in your answer, that's okay, because the signs really depend on which side of the equal sign you collected your dy dx's. So for instance, on well, I'll just take this one. For instance, on this one, if you had a negative 15x squared minus y squared plus 15x squared y to the third over negative this and positive that, that's okay. Okay, if every sign is different, just means you took it to the other side. Okay, and again, we'll go over that. I can take more questions about that on Friday. Okay, the last 2 questions were just derivatives of quotient rules. Okay, so again, I will, looking at this, I took the derivative of the left-hand side, just normal rules. Right-hand side, I had used the quotient rule. So if you remember, the derivative of the top, or the numerator, is just going to be a negative 1 dy dx times the bottom, and then minus derivative of the bottom, which is just positive dy dx times the top, 2 minus y. Okay. Down, next step, I went ahead and took out the dy dx. Okay. And then with this being a negative dy dx, I took out the dy dx, then had to distribute that negative. So I ended up with negative 2 minus y. Over here, when I took out the dy dx, I again distributed the subtraction. So I got -2 plus y. The y's canceled out, and I ended up with -4 dy dx is my numerator over 2 plus y squared equal to 6x. I multiplied by the reciprocal to get the dy dx all by itself, and I ended up with this. Okay. Again, when I with that -4 in the denominator, anytime one part of a fraction is negative, it just means the whole fraction is negative, so I wouldn't have brought that negative out front. I was able to divide everything by 2 to simplify, and I got this. Okay. Number 8 was a little more straightforward because the implicit differentiation was only on the left-hand side, and the right-hand side was just applying the quotient rule. So anyway, that might be a little straightforward. I think you guys can probably follow that. Again, check your homework, mark up anything you missed or have questions about, and we will spend a little bit of time on Friday going over this homework again, okay, just to answer any questions. But this is out in Content Library for you guys to look at. Okay, so as I said, our notes today are actually, I hate to say the word easy because nothing in calculus is easy, but they're a little bit not as difficult as actually taking the implicit differentiation of a function. So anyway, let's just get started. So what we're going to be doing today, if you remember, one of the applications of derivative, or what a derivative actually represents on a graph, is the slope of the tangent line at a given point, right? So we can create tangent line equations for a given point using the derivative. So we've done it quite a bit last semester using the regular derivative. Today we're going to use find the equation of the tangent lines using implicit differentiation. So the steps are really the same. We're going to take the derivative. Okay, so we're going to solve for the derivative using solve derivative for dy dx. But here what we're going to do is, because we're going to be given a point that we want to find the derivative for, so then we're going to substitute values in for x and y, and solve for m. So the dy dx in an implicit differentiation is actually your slope, just like any derivative represents the slope, okay? In implicit differentiation, your equation you get for dy dx represents your equation for your slope. Now, one little twist we're going to do a little bit different here than we did last time is our final equation. We're going to use point slope form. Now, I'm not sure if all of you have seen point slope form. Some of you should have seen some pre-cal. And it's an important form it's just another form of a linear equation. But all you need to write it is a point and a slope. So what this does for us is it gets rid of the need to solve for b, okay? So instead of doing a y equals mx plus b equation, okay, we are instead doing a point slope equation. And in this point slope, this is the format for point slope, and the y is a point value and the x is a point value, okay? So all you have to do is plug in those point values and plug in your m. Again, we'll be doing some examples of this, but so your homework, I would also like you to have your homework in point slope equation form, which actually you'll find is much, much easier than slope intercept. Okay, so let's try this a little bit. Let me put some explanation of those words. So we want to find the equation of the tangent line at a given point for each equation. So if we were in class today, I would kind of tease you guys about what type of equation this is. So x squared plus y squared equals 100. Hopefully some of you are like, oh, I know what type of equation that is. That is actually an equation of a circle, okay, with a radius of 10, right? Because a circle is x squared plus y squared equals r squared. So this is an equation of a circle, and it's saying give us the equation of the tangent line at the point 3, -7. So let's say we had a point 3, -7 down here. Here would be our tangent line, and we want to find the equation of this line. Okay, so again, to create an equation of a line, we need a point, which we have a point. So we have our x and our y values. Now we need slope. So to find slope, we're going to take the derivative using implicit differentiation. So the derivative would be 2x plus 2y dy dx equals 0. Now we solve for dy dx. So we get 2y dy dx equals negative 2x. We divide by 2y. And the 2's cancel out, and we get negative xy. So that is our formula or our equation for the derivative. We plug in our values for xy, so that becomes negative 3 over negative 7, which becomes 3/7. So that is our slope for our tangent line. And because we're going to use slope, point slope form, which again looks like this, our final answer is simply y minus 3 equals 3/7 x, sorry about that, I messed up there, y minus negative 7, which becomes y plus 7, equals 3/7 x minus 3. Okay, so that's it. So again, we've solved for dy dx, just like any implicit differentiation problem, and then we plug in our x and y values to turn that derivative into an actual value. So that gives us, and that value represents our slope. And then we plug in our x and our y values into our point slope formula, and voila, we're done. Okay, let's try another one. Okay, so again, so this equation, we're going to take the derivative, and we have to use our product rule. So derivative of the first, 2x times the second, right? Because x squared is our first function, y squared is our second, plus derivative of the second function, which is 2y dy dx times the first function, which is x squared, and then equals 0. So now, again, we get dy dx by itself, so I'm going to subtract. And I'm going to rewrite the term I have left to be a little bit more, make a little bit more sense. Okay, now I'm going to divide by 2x squared y. And what I'm left with, my 2's cancel out. I get a negative. This x cancels out with one of those, so I get an x on the bottom. And this y cancels out with one of those, so I get a y on the top. So I get negative y over x. So now I want to turn that into a slope. So I'm going to plug in my values of x and y. So that becomes negative 2 over negative 3. So I get 2/3. So 2/3 is my slope. I plug it into my point slope formula. And my answer is y minus 2 equals 2/3 x minus a negative 3 gives me x plus 3. Okay. All right. Now let's try another one. Now again, you're probably looking at this next one saying, oh, it's going to be kind of complicated. It has a radical, right? And so it's going to get a little strange. Now, the good part about this, what you're going to see here, is we can avoid a lot of the common denominator stuff that we had to do when we simply took the implicit took the derivative of this equation, we could avoid a lot of that by choosing when we're going to plug in our xy. Okay, so it makes this problem a little bit easier than it was when we just had to come up with the derivative. Okay, so I'll show you what I mean here right now. So take the derivative. So we get 6y. Actually, first let's rewrite this. 3y squared plus x to the 1/2 equals 23. Okay, so now I take the derivative. I get 6y dy dx plus 1/2 x to the negative 1/2, sorry, equals 0. Okay, so now I need to get the dy dx by itself. So I'm going to go ahead and subtract this from both sides. And I end up with 6y dy dx equals -1/2 x to the 1/2. Okay, now at this point, I'm going to go ahead and plug in my x and y values. So I don't even have to divide by that 6y. I'm going to go ahead and plug in my values. So this becomes 6 times 2 dy dx equals -1/2 and then 4 to the 1/2. Okay. If I keep simplifying, I end up with 12 dy dx equals -1/4, right? So 4 to the 1/2, right, is the square root of 4, which is a 2. So let me show that. I don't mean to be so. I've got 2 times 2, which gives me -1/4. Okay. Now, again, I want to divide by 12. So divide by 12. And remember, dividing by 12 actually just means multiplying by the reciprocal. So that really means multiplying by 1/12. And I get dy dx equals -1/48. Okay, which again is my m. Okay, now I need to write my equation. So again, I'm going to use my point slope form and just plug in the point and the slope. So my final answer is y minus 2 equals -1/48 x minus 4. Okay. So, actually, it doesn't really matter where you choose to plug in the x and the y values. Like if you noticed up here, I waited till the very last step to plug them in, but you don't have to. What I normally like to do on these, when they're a little more complicated, is I normally wait till I at least get the dy dx on one side, like all those terms on one side, and the others, the other terms on the other side. You wouldn't have to. That's just kind of what I recommend. Okay. So this next one is about is again the last one we're going to go over, and it's probably the most involved, but it's actually turns out not too bad with the plugging in pieces of it. So we want to find the equation of a tangent line at a given value of x. So the first kind of glitch here is that it's only giving us an x value. Well, for our equation, we're going to need a y value also. Okay. So again, anytime you have an x value and you need the y value, you have to plug in the x value into the original equation. So we want to plug 2 into our original equation to find y. Okay, so let's do that before we even start with the derivative. So we're going to say y cubed. So we're saying y cubed, because we don't know y, plus 2 times x squared. So again, I'm just plugging this in. 2 times x squared y minus 8y equals 2 cubed plus 19. So again, all I've done is everywhere I see an x, I'm putting a 2. Right? And otherwise, I keep it, I keep everything the same. So when I simplify that, I get y cubed plus 2 times 2 is 4, times 2 is 8, y minus 8y equals 2 to the third is 8 plus 19. Okay? When I simplify that, again, I'm solving for y because I need to turn this into a point. So those cancel. I get y cubed equals 27. And again, if y cubed equals 27 and we need to find y, then we are actually taking the cube root. And we get y equals 3. Okay? So now we know our point up here is 2, 3. So now again, when our final goal is a point slope equation and we filled in the point that we need, now we need to find the slope by taking the derivative. So I'm going to come down here and do implicit differentiation on my original equation. Okay, and we get 3y squared dy dx plus, now again, I need to take I need to use product rule here. So I'm going to say derivative of the first is 4x times the second plus derivative of the second times the first minus 8 dy dx. Actually, minus 8 dy dx equals 3x squared. Okay, so again, this is the implicit differentiation of that original equation. Okay, now what I'm going to go ahead and do is collect my dy dx terms on one side. So over here I have dy dx, and I have 3y squared plus 2x squared minus 8. And over here I have my 3x squared, and then I'm going to subtract my 4xy. Okay. Now, at this point, I'm going to go ahead and plug in my 2 and my 3. So I have x equals 2 and y equals 3. So I'm going to go ahead and plug those in to find my slope. So I say dy dx equals 3 times 3 squared plus 2 times 2 squared minus 8 equals 3 times 2 squared minus 4 times 2 and times 3. So again, I just took my point I know, 2, 3, and plugged it in. So now I get dy dx. 3 times 3 is 9, times 3 is 27, plus 2 times 2 is 4, times 2 is 8, and then minus 8 equals 2 squared is 4, times 3 is 12, minus 4 times 3 is 6, times 4 is 24. Now when I simplify this, 27 plus 8 minus 8 gives me 27 dy dx equals negative 12. I divide by 27 and I get negative 12 over 27, which if I take out a 3, I get negative 4/9. So that's my dy dx, and that's also my slope. Okay, so now I have my x and my y, and I have my slope. So the big finale would be y minus 3 equals -4/9 x minus 2. Okay. So again, all we're doing here is taking the derivative using implicit differentiation, just like we have been doing. And then at some point, again, you can kind of choose your point. Just be careful to be aware of where you are in the problem. You substitute your x and your y values into your derivative, solve for dy dx, which will be a value that represents your slope, and then plug it into your point slope formula, again, along with x and y. Okay, so your homework is just a couple of these type problems that really go directly along with our examples in the book. So these first three are just like our first three examples where you're given both x and y values, right? So you're given x and y, you're given a full point, okay? Follow the process we just did. On 27 and 28, you are just given an x value, okay? So you have to find the y value, again, by plug x into original equation and solve for y. And then take the derivative to find m. Okay, and then plug in the formula. Okay, so anyway, I hope that wasn't too painful for you guys. Again, we'll go over this on Friday. We'll take any questions along with going over the homework that we checked today. So hope you guys enjoy, like I said, enjoy this beautiful weather. Hopefully this is not like midnight Thursday night when you're doing all this, which is no judgment. But anyway, I will see you guys at school on Friday or virtually. So have a good couple days. Bye, ladies.